Hi there. So this video is going to take you through some of the geometry concepts that you've been learning about through your vocabulary. And part of what I'm going to be doing in this series of videos is start getting you familiar with writing geometry proofs. Okay, I'm going to ease you into it. It's a very common thing that you do in geometry. So when you take a college geometry class or later on in this semester, you're going to be writing a proof. Proofs are basically what they sound like. You have to prove why something is what it is. And when you apply it to geometry, it's a very straightforward. It just is what it is, okay? So anyway, so I'm going to start getting you used to that language and what to expect for writing a proof. All right, so let's just dive in. The first concepts I'm going to talk to you about are some of the angle concepts. You've been defining those. We're talking about straight angles, congruent angles, angle bisectors, supplementary, complementary, vertical, adjacent, all that fun stuff. So that's what I'm going to start with here, okay? So the first thing I'm going to do is I'm going to give you some information. And in a geometric proof, okay, remember that's what I'm going to ease you towards, that's your given information. They literally write given. So given line L is parallel to line M. Okay, so when you write this out using letters and symbols, okay, typically when they give you lines, they're going to call them L and M and N. Those are just very common names for lines when you're doing geometric proofs and that sort of thing. So, and then the two vertical lines in between there obviously represent parallel. So when you read this out, it's given line L is parallel to line M. Okay, and what that looks like in your drawing, let me change colors here, is, okay, and I'm going to call that one L. There's line L. And down here is line M. Now, one thing you need to remember with geometry is never assume anything. Just because it looks like something, like it looks like it might be a right triangle or two shapes look like they're congruent, that does not mean that they're actually congruent or it's actually a right triangle. You always have to prove and know for a fact. And you're going to base your information off that given information. All right, so I've given you that line L is parallel to line M. Okay, now if you remember back to Integrated Math 1, parallel lines have the same slope. Okay, so just kind of keep that in mind as we go on. Now the next thing I want to draw for you is a transversal. And let's change colors again. And a transversal is simply a line that intersects line L and M. Okay, so I'm going to call that one line N. Okay, so we've got our transversal. Now, the next thing I want to show you is we're going to start applying some of our angle information here. Okay, so one of the things that you can hopefully just look at and understand, this angle here plus this angle over here is going to add up to 180 degrees. So we're going to call this angle 1, and we're going to call this angle 2. If I add the angle measures for angle 1 and angle 2 together, that's going to give me 180 degrees. So if angle 1 plus angle 2 equal 180 degrees, we can say that those two angles are supplementary. Okay, so when we write that in geometry speak, we would say angle 1 plus angle 2 equals 180 degrees, which means that angle 1 and angle 2 are supplementary. Okay, so they're supplementary. So this is getting you, again, easing you into a geometric proof. Now, right now, we're not trying to prove anything. I'm just letting you know how you'd write that. Okay, so knowing that, next thing I want us to do is look at vertical angles. And I'm going to change to blue here. Let's go down here to this intersection of lines. Vertical angles are angles that share a vertex, and remember your vertex of an angle is the point where your two rays meet. Okay, so that's your vertex. Okay, and so they're vertical because they share a vertex. So what I'm going to do first is identify some vertical angles. Here is an angle. Here is an angle. I'm going to call this angle 3. And I'm going to call this angle 4. So angle 3 is a vertical angle with angle 4. So we would say that angle 3 and angle 4 are vertical angles. Now, the cool thing about vertical angles, which I'm sure you found in your definitions, is that they're congruent. They have the same measure. So angle 3, since they are vertical angles, that means that the measure of angle 3 equals the measure of angle 4. Okay, so that's really important for you to just go ahead and learn and understand, is that vertical angles have the same measure. Now, the cool thing about this right here is we actually have two sets of vertical angles. I want to change colors on you again because I'm going to name this one angle 5. Can you see the 5? And angle 6, because angle 5 and angle 6 are also vertical. So I'm going to put this over here to the right. Angle 5 and angle 6, vertical angles. Alright, which tells us again that the measure of angle 5 equals the measure of angle 6 because they are vertical angles.